Hi everybody, today we are going to talk about similar triangles. So there are three ways that we can identify similar triangles. So the first way is called angle-angle similarity. So actually we can determine that two triangles are similar just by knowing that two pairs of congruent angles exist. So if you have two triangles and we have something like this is enough information for us to say that the two triangles are similar, and we would justify that with angle-angle similarity. The second way we can identify similar triangles is using side-side-side similarity. So for something like this, all three corresponding sides must be proportional. So you would have something like one side is 2, one is 4, maybe a 3 and a 6, maybe a 5 and a 10. So you can see that all three sides are proportional, and you do have to test all three. The last way that you can identify two similar triangles is using side-angle-side similarity. So this is if you have two corresponding sides that are proportional, such as 2 and 4, and then a 3 and a 6, and then you have a pair of included angles that are congruent. So included angles are the angles that are in between the two sides that we use. So it has to be the angle that is in between the sides. So if it's not, then we cannot claim side-angle-side similarity, and you would just say that it is not similar. So make sure that when you are doing these problems that you are actually looking for the included side. So we're going to practice identifying similar triangles now. So here we have what looks like a single triangle, but if you actually think about it, it's actually two, because we have one large triangle here, and then we have a smaller triangle within it. So when I'm doing problems like this, I like to give myself a list of options that I have to prove similarity. So these are my three options. Now you might notice that we're not given any of the side lengths of either triangle, so I can automatically eliminate both of those two methods. So now I'm going to see if there's any way I can use angle-angle. So what you might notice is that we have these two lines with the little arrows on them, so hopefully we remember that that means that the lines are parallel. So here we have two parallel lines cut by a transversal, and we can look for some angle relationships. So we actually know that this angle is congruent to this angle because they are corresponding angles, which are congruent when we have two parallel lines. And we can also use this transversal. So we have two parallel lines cut by a second transversal, meaning this angle is actually congruent to this angle for the same reason. And in fact, we can also say that this angle down here is congruent to itself because it's part of both triangles. However, we don't even need to prove that because we only need to prove that two of the corresponding angles are congruent. We've already done that. So we can say that these two triangles are similar because of angle-angle similarity. And that's our answer. All right, let's try one more together. So once again, I'm going to give myself a list of possibilities. So here you can see that we are only given one of our angles, and there's no way to find the other ones. So we can automatically eliminate angle-angle. Now, if you look at what we're given, we have two of the sides, and we do not know the third. So that means that we can also eliminate side, 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 which means we might be able to use side, angle, side. But you have to be careful, because if you look at the sides that you're given, you might notice that the angle is not in the correct place. So we're actually looking for the angle that's right here. This is the included angle, which means that this is not the included angle, which means it's not the correct piece of information for us. So remember, the angle needs to be right in the middle of the two sides. So that means that angle side does not work either. So that means that we don't have enough information, or so we can say that these two are not similar. All right, go ahead and pause the video and give this problem a try. Okay, so for this problem, you can probably guess that we're going to check to see if it's side, 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 because we don't know any of the angles. So we need to create a ratio for all three sides. So we know that 7 would go with 14. And if I simplify that ratio, it's 1 over 2. Well, we can match the other 7 with the other 14, which is also 1 over 2. And then we see that side 3 will go with the side with length 6, which is also a 1:2 ratio. So since all three sides are proportional, we can say that these two triangles are similar because of side, side, side similarity. All right, go ahead and pause the video again and give these two problems a try. So looking at this problem, you might notice that we have one pair of congruent angles, but the other two don't match. However, we can find that missing angle in either of our triangles. So we know that the three angles should add up to 180, which means that this angle right here must be 40. So when you find that, we actually have our second set of congruent angles. So you don't even need to find this third missing angle, although you could, because we already have enough information to state that these two triangles are similar because of angle-angle similarity. So always remember that if you have two of the angles within a triangle, you can always find the third angle. Okay, we're going to try a different type of problem now. So here you can see that they would like us to actually find some side lengths. So one thing you have to be very careful about is that you can't set up a proportion with the sides until you know that the two triangles are similar. So step one with these types of problems is always going to be to prove the similarity between the two triangles. So when I'm looking at the two triangles, the first thing I notice is that these two angles are congruent because they are vertical angles. And then another thing I notice is that we have two parallel lines cut by two transversals actually, but let's use this transversal. Using that transversal, we can say that this angle right here is congruent to this angle down here. So with these two angles alone, we have enough to state that the two triangles are similar because of angle-angle similarity. So now that I know that the two angles the two triangles are similar, I can move on to step 2, which is to create a proportion with the corresponding side. So I know that 2 will go with 5. So we could say 2 over 5 equals, I know that x minus 1 goes with x plus 5 because they're the two that are squished between our two congruent angles. So from here, we can cross multiply. So we have 2 times x plus 5 equals 5 times x minus 1. So we are going to need to distribute. And then I'm going to subtract 2x from both sides. And then add 5 to both sides and divide both sides by 3. So we get x equals 5. But if you look back at what they're asking us to find, they're actually asking us to find the lengths of AE and DE. So we have one more step. Step 3 is going to be to substitute to find those lengths. So we know that AE is x minus 1 We substitute x with 5, so AE is 4. And then we know that DE, it's right here, is x plus 5. Then we substitute x equals 5. So DE equals 10. And then we're done. So, alright, so go ahead and pause this video and give this last problem a try. Okay, let's go over it together. So remember, step 1 is to prove that the two triangles are similar. So we already have one set of congruent angles, and we know that these two angles are congruent because they are vertical. So we know that the two angles are similar, the two triangles are similar because of angle-angle similarity. So now we can move on to step 2, which is to create the proportions. So we can create our proportion by saying 8 over 10 equals x plus 6 over 2x plus 3. So we can cross multiply. So 8 times 2x plus 3 equals 10 times x plus 6. So 16x plus 24 equals 10x plus 60. So I'm going to subtract 10x from both sides. And then I'm going to subtract 24 from both sides and divide by 6. But remember, we're not trying to find x, we're trying to find the lengths of WR and RT, which brings us to step 3, which is to substitute. So we know that WR is x plus 6. We know that x is equal to 6, so WR is 12. And then we know that RT is 2x plus 3. So substitute x equals 6, which means that RT is 15. So those are two answers, and we are all set. That's all for today. Thank you for watching.